Welcome back. This is Mr. Green Science Geometry, and we're part 2 of section 4.2, reflections. Let's look at the rules for the reflection. The first one is across the x-axis. So if we're going to go across the x-axis, we're going to take AB, which is the xy components, and we're just going to negate the y component. If I go across the y-axis, I'm going to take the AB components and then I'm going to negate just the x part. If I go across the line y equals x, I take AB and I just swap them so that it becomes BA, just like we learned in the last slide in part 1. And then across the line y equals minus x, we take AB, we swap them, and we negate both of them. Reflection postulate. So the reflection postulate says that a reflection is also a rigid motion, just like translation is a rigid motion. And we also call that a congruent motion or congruent transformation. No, I still can't get that right. Okay. My writing is a little bit kind of dicey there. A glide reflection is where you move something in a translation and then you reflect it. So you glide it. So we have this pre-image over here, PQ. We're going to glide it or translate it to P prime, Q prime, and then we're going to flip it over the line of reflection, and that becomes the image over here. So that's a glide reflection, which is two motions. So we have this pre-image. Let's take our pre-image of 1, 3. So that's A. B is 5, 2. And C. And we'll put those together and perform a glide reflection. So we have a translation which says that we're going to first move 5 and then minus 1. So that becomes A prime. B prime is and C prime. So there's our glide. And then we want to reflect around x equals 3. So x equals 3 is here. And if we do that, then B is going to be, let's see, way over here. So B double prime is going to be here, and C is going to be there, and A double prime is going to be here. So then we put this back together again, and there's our final image. So we've done a glide reflection about the reflection around x equals 3, and we've done the translation of 5, comma, minus 1. Line of symmetry. So line of symmetry is really the reflection line. So if you see here, the line of symmetry, a figure can be mapped onto itself by a line of reflection line. So if we have a point P and another point P prime, we could say the line of symmetry is the line that is the perpendicular bisector of this segment. Pre-image, image. The line of symmetry is the reflection line itself. So the line of symmetry and the reflection line are the same thing. Let's look at the waterline problem. Two buildings are located at A and B, and they can only be connected one point on a water line, and we want to use the least amount of pipe. So what we're going to do is we're going to use a reflection property. We're going to take A and we're going to reflect it across that water line to the other side. And if we do that, we get a point here, which is called A prime. And then we connect those 2 points, B to A. And the shortest distance between 2 points is a line. So the place where we're going to make our connection is right here. So this is going to be the shortest distance if we're just going to connect to one place on the water line. And we use reflection to find that location. How many lines of symmetry does each figure have? So if we look, A, we can see that there's a line of symmetry here if we drew a line because the points map the same, reflect the same around that. Does it work anywhere else? Not really. So there are 2 lines of symmetry. There's a line that goes down this way and a line that goes across this way. How many lines of symmetry do you see here? There are 6 lines of symmetry. There's one that goes through each pair of opposite angles, and there are 3 more that go through the middle of each one of the sides. What about the lines of symmetry here? There's only 1 line of symmetry. If you try to draw any other line of symmetry, you'll see that it does not reflect around that line. So that concludes reflections, and we'll discuss more of this in the next day of class.